This is the first video lecture for week 3. With this, we start the topic number 2, differentiation. In this topic, we study secant line, tangent line, average velocity, and instantaneous velocity. So let's see first the secant and the tangent line. Note that for every function y equal to fx, there is a graph. That means for a function, I can always draw a graph. So here, this black is the graph of the function y equal to fx. For this graph, if I draw a line which is cutting at 2 points, this and this, that means this blue line is known as secant line. If this point is merges with this, that means it approaching, and suppose if it is what you call merges with this point, then this blue line becomes a red line, and that is known as the tangent line. So in that case, let's say some examples here. I have a what you call graph for some function which is shown in blue. Then I draw a secant line joining the point 1, 2 and 3, 10. So this is the red line. If I take still closer what you call point, instead of 3, 10, if I take 2, 5, then the secant line we have this. Still there are 2 points here. If I take still closer, instead of 2, 5, if I take 1.05 and 2.1025, means again I have taken 2 points. Yes, you can't see here the point. If you enlarge it, you see that these are the 2 points here. So these are all the what you call secant line. Here we use the idea of geometry, that if you want to find the slope of a line joining the 2 points a comma fa, a plus h, f of a plus h, these are the 2 points given, and if you are asked to find the slope of a line joining these 2 points, that means I am finding the slope of the secant line joining these 2 points, then I denote the slope of the secant line by m sec. So I take the difference in y coordinate, difference in a coordinate. So I take this minus this divided by this minus this, right? Then this a and minus a cancels, then we get this quantity. So this is the formula to find the slope of the secant line or any line with 2 points given. This quantity is known as different quotients. In this, as h approaches 0, then the slope of the secant line approaches 2. Look at it. Then we get a tangent line, that means slope of the tangent line. So therefore, I will define now the slope of the tangent, which is denoted by m tan to this graph at this point, is just the same quantity, but now I will find the limit as h tending to 0, because as I say, as h approaches 0, the secant line becomes the tangent line. So this is the formula of the what we call the slope of the tangent line. So the difference between the secant line and the slope of the secant line and the slope of the tangent line is that this is just a difference quotient, and this is, for this difference quotient, we find the limit with h tending to 0. If you want to find the equation of the tangent line, equation, now look at it, this is the slope of the secant line, this is the slope of the tangent line. Now I am finding the equation of the tangent line, which is given by y is equal to m tan, that is the slope of the tangent line, x minus a plus fa. This a and fa, I mean the point passing through that. The tangent line is the line passing through. That means it is cut at this point. So this is three formula you're remembering: the slope of the secant line, the slope of the tangent line, and equation of the tangent line. Let's see one example here. Find the equation of the tangent line to this graph at this point. So I go back to the earlier formula, that is m tan is f of here a is equal to 1. So f of a plus h become 1 plus h, then minus f1 because x a is 1 here. So f of 1 plus h, so I put it here because this is fx. Fx is x square plus 1. Therefore, f of 1 plus h means this x is replaced by 1 plus h. So 1 plus h square plus 1 minus f of 1 means I put fx is x square plus 1, that is f of 1 is 1 square plus 1, that is 1 plus 1. I what you call expand this 1 plus h square, it has three terms, then you have plus 1 and this is 1 plus 1 is 2, then I subtract, I get this. Then I can take common h here, right, and then I cancel this, I get this. Then I find the limit of this. Remember, h tending to 0. The only difference here is that instead of x tending to 0, here you have h tending to 0 means no denominator. I put h equal to 0. Then I get 2. So this is the slope of the tangent at this point. Now I will find the equation of the tangent and at point, because this is only the x coordinate, I put x is equal to 1 in this, I will get the y coordinate. That means the point is 1 comma 2, right? So this is the point 1 comma 2. The slope we found it. I just substitute in the earlier what you call formula. So y is equal to slope x minus 1, that is a, and this is fa. This is fa. I simplify this, I will get y is equal to 2x. Another example. Find an equation of the tangent line to this graph at x is equal to 2. Similarly, here a is 2, so f of 2 plus h minus f2 divided by h, limit for that. So f of 2 plus h, that means this x, I will put this is y equal to fx, right? So x is 2 plus h, therefore it is 2 upon 2 plus h minus 1, because f of 2 is 1, because I put x is equal to 2, 2 cancels, you get 1, right? And then I will cross multiply this, that means 2 minus 2 plus h divided by h by h. Then I open the bracket, minus 2 minus h, 2 cancels, you get minus h. There is already h here, so this will come down, right? So this h and h cancels, so minus 1 divided by 2 plus h. Let's find the limit of this as h tending to 0. So here we have a denominator. I put h is equal to 0. The denominator is not 0. So I directly substitute minus 1 by 2 is the slope of the tangent line to this graph and at this point. So I put x is equal to 2 here. I will get 1. Then your point is 2 comma 1. So the equation of the tangent line is y equal to slope x minus 2, that is a, and this is fa. So this is the equation of the tangent line. Then we have average velocity. Average velocity is defined as displacement divided by time. So the only difference here is that instead of fx, we have s of t. So f is s, x is t here. So fx is a function. Now st is a function, and since it is dealing with position, so therefore it is known as position function. So st is a position function which is given, which is just similar to y equal to fx. Then the average velocity is exactly same as slope of the secant line. But the only difference here is that average velocity is displacement divided by time. So I put t equal to b, see sb minus sa divided by b minus a. So this is the formula for finding the average velocity. For example, the position of a car after t times driving in a straight line is given by this. This is the position function, that is y equal to fx is nothing but now s of t. This is f, this is x. And the time is from 0 to 4, and here t is measured in minute, that is 0 to 4 minute. S is measured in miles. The question is here, approximately find the velocity at time t equal to 2. So velocity, here you are asked to find the average velocity. So what we will have to do here is that I have to take the 2 points here. So the question is here, approximate the velocity at t equal to 2 mean I will take that and I take one more point here. That means a distance of 2, what you call at time 2. So 2 and one more value I will take 2 and 4. So I will take here. So look at it, you are not going to exceed here. So 0 to 4. So I have been asked to find the velocity at t equal to 2. I take that and I will take one more point t equal to 4. So I use this formula S4 minus S2 divided by 4 minus 2. So I substitute this in this formula, I get this, I subtract, I get this. So this is the 40 mile per hour is the velocity at time equal to 2. If we reduce instead of 2 minute, 1 minute, then it is S3 minus S2, 3 minus 2. Again I substitute and I get that. So this is the better what you call value for the average velocity. So what we do here is that we go on reducing these, I mean if we go on reducing the distance, what you call the time between the 2 points, we will be getting the better result. So for that we need to define what you call the average velocity now becomes the what you call instantaneous velocity. So what I will do, if I find the limit for that what you call average velocity, I am getting the instantaneous velocity which is denoted as v of a. So v of a is the instantaneous velocity. For the average velocity, I am finding the limit. So it is exactly finding the slope of a tangent line. The average velocity exactly finding the slope of the secant line. And if you leave if you take only the absolute value, that means no direction, that means only the magnitude, then it is the speed. So please remember, average velocity different, the instantaneous velocity is different, and the speed is different. Okay, so we will continue in the next video lecture more details.